Solar systems, the building blocks of our cosmic neighborhood, are no longer as they once were. A staggering 771 trillion solar systems have mysteriously disappeared, leaving the scientific community baffled. What follows is nothing short of mind-boggling. From the depths of space, unfamiliar entities have begun to surface, compelling us to uncover the truth behind the abrupt disappearance of 771 trillion solar systems in our vast universe. Could there be a connection between the vanishing solar systems and these enigmatic apparitions from the cosmos? Join us as we embark on a journey through the unfolding cosmic mysteries of vanishing stars. Over 771 trillion solar systems have vanished, and an unsettling phenomenon has emerged from the cosmic void. We will delve into the potential explanations behind the disappearance of solar systems and investigate the appearance of this perplexing cosmic phenomenon. Humanity has spent thousands of years understanding concepts like science and mathematics, which help us comprehend our place in the universe and the basic nature of Earth. Even though the core remains a mystery, one fundamental idea is that matter doesn't just disappear, it transforms. Similarly, when a star explodes and disappears, its material scatters across the cosmos, enduring in a different form. This raises an intriguing mystery in outer space, the vanishing of stars from our night sky. At first glance, this might not seem particularly surprising given the vastness of the universe. Stars can vanish suddenly for various reasons, like reaching the end of their life or getting pulled into a massive entity such as a black hole. However, what makes this situation perplexing is that it's not just a few stars disappearing. There are countless stars, more than 700 trillion, that have mysteriously gone missing, leaving astronomers baffled about how they could have blinked out of existence so abruptly. While a few disappearing stars can be explained in a universe as vast as ours, the vanishing of hundreds of trillions, especially those that aren't nearing the end of their life cycles or threatened by external forces, presents a completely different problem. Fortunately, a group of dedicated scientists is tirelessly working to unravel the mysteries of the cosmos. Beatrice Villaroel from the Nordic Institute for Theoretical Physics in Sweden sheds light on their endeavors, explaining that their project, known as VASCO, is a significant undertaking. Their primary goal is identifying a star that has remained a constant presence in the night sky for as long as human memory and available records can recall, only to vanish suddenly without a trace. This, even the most advanced telescopes have failed to detect any remnants of such stars. Villaroel underscores that this is not merely a whimsical pursuit. The VASCO project has been active since 2017 and has garnered considerable attention. Each of them is driven by their unique motivations to participate. The team acknowledges that certain aspects of the universe remain unpredictable due to vast distances, making it challenging to catalog every celestial object with absolute precision. However, they maintain their confidence in the potential of discovering a specific type of star suddenly vanishing from the night sky, a phenomenon that has not been documented before. Villaroel emphasizes that while variable stars exist, their changes typically occur over a few years at most. The quest is to locate a star that transitions from unwavering stability to complete disappearance, a discovery that could potentially unlock new frontiers in the realm of physics. You might be wondering, is it genuinely conceivable for a star to disappear without warning? The answer is affirmative. For example, there was a star that astronomers closely monitored for an extended period spanning 2 decades until 2019. This star drew their fascination partly due to its dazzling crystal blue radiance. Then, suddenly, it vanished from their observations. Andrew Allen, a doctoral student specializing in astrophysics at Trinity College, Dublin, meticulously examined and re-examined the data. The prevailing theory suggested that the star had undergone a supernova explosion, transforming into a black hole. However, there were no discernible signs of a supernova event or the anticipated aftermath. Furthermore, there was no observable black hole. Taking into account the time gap between observations, it seemed highly improbable that such a dramatic event could have gone unnoticed. If indeed the star had transitioned into a black hole without any supernova activity, it represents a scenario of vanishing without the usual spectacular display, a phenomenon that has left astronomers seeking answers for an extended period. Clues pointing to such occurrences date back to 2009, when a star that had garnered attention from numerous telescopes appeared to be nearing a climax. This star underwent an abrupt transformation into a black hole before scientists could fully grasp the intricacies of the process. While concrete evidence remains elusive, this event left astronomers in a state of puzzlement. Equally significant is the collaborative effort of multiple research teams, including those mentioned earlier, in compiling comprehensive star catalogs and their characteristics. These catalogs enable astronomers to access star data online and conduct extensive comparisons. The findings have been both encouraging and astounding. As one researcher pointed out, they have identified numerous short-lived transients that briefly appear in one image before disappearing, constituting the majority of their discoveries thus far. However, there are still other phenomena that defy immediate classification. An examination of some of these fleeting transients ruled out possibilities like M-dwarf flares or nova occurrences. Building on this, a prevailing notion among certain astronomers is that the disappearance of these stars may be linked to the way light traverses the vast expanse of the universe. Imagine having a light source in your room and then walking away from it until it vanishes. Now, extend that distance across galaxies. This raises the fundamental question of how we can perceive anything at all. The answer lies in the fact that the countless light rays emitted by these stars take an extraordinarily long time to reach us. Even when they eventually arrive, they blend with the rays from our sun, enhancing their visibility in our night sky. In reality, the light we see is, in many cases, many years old. In the case of our sun, which is relatively close, its rays still require approximately 8 minutes to reach Earth. When we apply this to stars situated light years away, the age of the light we perceive becomes remarkably evident. This seemingly immediate disappearance of stars might be a result of the immense age of the light we observe. Although it appears instant to us, the star could have ceased to exist long ago, and we are only now realizing its absence. This also ties into the concept of stars going through extended periods of brightness, followed by fading, until they reach a point where they are no longer detectable. It's a complex notion, and while unproven, these questions must be raised to uncover the truth behind these phenomena. Some individuals are drawn to exploring Dyson spheres, the more extraordinary possibilities within these theories. For astronomers, one prominent theory concerning vanishing stars involves contemplating the role of extraterrestrial beings. You might wonder, how could extraterrestrial beings cause stars to disappear? The answer doesn't lie in making stars vanish, but rather in the intriguing possibility that these massive celestial giants might be utilized for their own purposes. Have you ever come across the concept of a Dyson sphere? While it currently resides in the realm of science fiction, it envisions the scenario where advanced alien civilizations or exceedingly rare events on Earth involve constructing a specialized megastructure encircling a star. This megastructure serves as a means to capture and harness the star's energy on an enormous scale, effectively transforming the star into a colossal energy source, or even a formidable instrument of power. This notion bears a resemblance to the scenario depicted in Star Wars. The Force Awakens, where the Starkiller base harnessed a star's energy to obliterate several planets of the Republic. However, the feasibility of such an explanation faces substantial obstacles. Firstly, the existence of extraterrestrial life remains unconfirmed. Furthermore, the realization of a fully functional Dyson sphere, even around a relatively modest star, would demand an extensive amount of time and a level of technological sophistication that surpasses our current capabilities. When we contemplate applying this concept across more than 700 trillion stars, it becomes an immense galactic endeavor with questionable likelihood. Nonetheless, this concept still maintains its proponents. So, where does this leave us? The answer is that we are left without definitive answers. What we do know is that something remarkable is unfolding in the cosmos, leading to the disappearance of stars from our observations and our view. This cannot be dismissed as a random occurrence, as we have observed the conspicuous absence of numerous stars. The central question that lingers is, what is causing such a substantial number of stars to vanish within a relatively brief span of time? This is precisely why individuals and organizations from diverse disciplines are committed to unraveling this mystery. Discovering answers to these questions could potentially provide us with a deeper understanding of the universe. If similar phenomena emerge in the future, we may be better equipped to promptly decipher their causes. Voids. While the enigma of star disappearance continues to perplex us, something novel has recently emerged from the depths of the cosmos. Scientists have, in recent times, stumbled upon vast voids in space that surpass our initial assumptions. These voids encompass a scale that stretches from the solar system to the Milky Way. The universe is filled with such voids, expansive regions where celestial entities are notably rare. Among these, one extraordinary void stands out, the Boots Void, often referred to as the Great Nothing. When you look up at the night sky, it often seems like a vast, evenly scattered expanse of stars. But in certain areas, like the Boots Void, things are quite different. These regions contain very few celestial objects. In essence, the universe has a unique structure, long threads of dark matter weaving through galaxies and groups of galaxies, with big empty spaces in between. The Boots Void has a diameter of about 330 million light-years, situated near the Boots constellation and approximately 700 million light-years away from us. Originally, this void had just one galaxy, but since its discovery, we have found only a few dozen more. The average gap between these galaxies is about 10 million light-years, which is 4 times greater than the distance between Earth and the Andromeda Galaxy. This contrast becomes clear when we compare it to our local cosmic neighborhood, the Virgo supercluster. The Virgo supercluster is smaller, about 110 million light-years in diameter, and is home to over 2,000 galaxies, including our Milky Way. To give you an idea of the vast emptiness of the Boots Void, the astronomer Greg Aldering once said that if our Milky Way were at the center of this void, we wouldn't have known about other galaxies until the 1960s. In comparison, the Milky Way has about 24 neighboring galaxies in a region only 3 million light-years across. Considering the size of the Boots Void, it should theoretically hold around 10,000 galaxies based on the typical distances between galaxies and the rest of the universe, which are usually a few million light-years apart. Surprisingly, we've only identified 60 galaxies within this huge void, making them some of the loneliest galaxies out there. The Hubble telescope even captured an image of one of these galaxies, MCG plus 01020015, a spiral galaxy residing in the Boots Void. The European Space Agency has described it as the loneliest of galaxies. How it ended up so isolated remains a mystery. In the image, you can see 3 stars in the foreground, all from our Milky Way. Everything else that looks like points of light are distant background galaxies, resembling a swarm of tiny organisms in a droplet of water. How do these voids form? Computer simulations have shown that smaller, more common voids result from the gravitational pull of galaxies, bringing them closer together and leaving empty spaces behind. However, this explanation doesn't apply to the Boots Void, because there simply hasn't been enough time since the universe began for gravitational forces alone to clear out a space of this enormous size. This leads us to the Big Bang Theory. When most people envision the universe's expansion following the Big Bang, they probably imagine galaxies evenly spread out, moving away from each other. However, a more intricate structure reveals itself when we examine the universe on its grandest scales, like trying to fit billions of light-years into a computer screen-sized cube. Let's rewind the universe's clock back to its early moments, shortly after the Big Bang. At that time, the universe was a highly compressed area of intensely hot plasma. Despite being mostly uniform in density, there were small variations or quantum fluctuations in space-time. As the universe expanded, these tiny variations in matter density became more pronounced. As a result, Regions with higher and lower matter densities emerged on cosmic scales. Fast forward 13.8 billion years from the Big Bang, and we can observe how these minute deviations at the beginning of time turned into the massive structures we see today. These structures are like enormous walls, each composed of thousands of galaxies instead of individual ones. They are linked together at nodes where filaments of galaxies converge. These structures are gigantic, spanning thousands of galaxies wide and hundreds of millions of light-years in size. The spaces or voids between these clusters of galaxies are even more vast. These voids aren't entirely empty. They have less matter compared to regions filled with galaxies. Their matter density is typically about 1/10 of the universe's average density, so these voids still contain dark matter, gas, dust, stars, and galaxies, although in smaller quantities. For instance, there are 17 different galaxy clusters within the massive void alone. As the universe keeps expanding, these voids, just like the Boots void, will continue to grow. The walls and filaments connecting clusters of galaxies will stretch and break apart, leaving behind only gravitationally connected galaxy clusters in the expanding voids. As these voids merge, the sheer size of the observable universe becomes truly astonishing. Meanwhile, we are situated within this vast cosmos, part of the local group, a component of the Virgo supercluster found on the edge of an immense cosmic void. But there is still much more to discover in this vast expanse. So far, astronomers have identified the largest known structure in the cosmos, a massive void known as the supervoid. This supervoid stretches a staggering 8 billion light-years in diameter and stands out for its incredible emptiness. The supervoid provides answers to questions that have intrigued scientists for over a decade, while also raising new questions that suggest the emergence of unique physical phenomena. The amount of cosmic matter, including galaxies and dust, within the supervoid is roughly 20% less than what you'd find in our region of the universe or any area with a typical density. While it's not completely empty, it does feel like an enormous and cold desert compared to other parts of space. The existence of this supervoid is linked to the discovery of the cold spot, a region in space noted over a decade ago for its unusual size and lower temperature. This is different from what we would have expected based on its cosmic microwave background, CMB radiation, which is the thermal radiation left over from the Big Bang. Scientists have been on the hunt for a void in this region because as photons travel through an expanding universe, they lose energy and cool down. When passing through a void, scientists have known for quite some time that confirming the extremely low density in this region would help explain why the cold spot exists. This phenomenon happens because as photons move away from denser areas of the universe and into the center of a void, their kinetic energy gets converted into gravitational potential energy. This energy conversion leads to a drop in temperature, making light leave with a longer wavelength and a colder temperature. To figure out how many galaxies were in a region of space roughly 3 billion light-years from Earth, Istvan Sapudi from the University of Hawaii and his team took up the challenge. The team included Andris Kovacs from Eötvös Loránd University in Budapest. They used the Pan-STARRS 1 telescope in Hawaii and NASA's Wide Field Infrared Survey Explorer satellite. Their findings revealed that the cold spot indeed exists within a significant region that's sparsely populated with galaxies. Even though this structure might not look like a standalone entity, it's quite remarkable considering that the typical distribution of matter in the cosmos is relatively uniform on this scale. Unfortunately, only about 10% of the temperature difference between the cold spot and the average temperatures of neighboring galaxies can be attributed to the supervoid. Now, let's go back to the Boots void. It wasn't until the discovery of dark energy in 1998 that we had an explanation for it. Dark energy is a mysterious cosmic force that causes empty spaces to expand as if the entire universe were inflating all at once. Many astronomers believe that these mysterious regions, which reveal the fundamental structure of the universe, could serve as markers for significant discoveries to come. There's been a surge in efforts to catalog and map these voids, allowing us to measure dark energy, gravity, and potentially new unforeseen forces with greater precision through statistical analysis of their shapes. Moreover, recent evidence suggests that the vast expanses of near-empty space that dominate the universe might be accelerating its expansion. This implies that dark energy, the mysterious force believed to be pushing the universe apart, might be linked to these extensive areas of emptiness. In simple terms, the universe is getting bigger every day, constantly expanding with each passing moment. The phase of this accelerated expansion, which seems to have started around 5 billion years ago, remains a puzzle for astronomers. Dark energy is the clever name given to this vast cosmic mystery. But what does dark energy have to do with these cosmic voids? One significant reason is that the effects of this accelerated expansion aren't noticeable within star systems or galaxies because gravity from matter dominates. For instance, dark energy hasn't caused the Milky Way or our solar system to expand. However, since cosmic voids are extremely lacking in matter, they are much more susceptible to the influences of dark energy. Therefore, it makes sense to explore the nature of this accelerated expansion in the regions where it has the most impact. A recent study suggests that dark energy isn't just present in voids, it might actually be a result of their existence. This raises the intriguing question of how these immense void regions could trigger a faster expansion of the universe.